Hi everyone! In this video, we are going to be talking about heat and temperature. Now, a lot of you probably think that heat and temperature are the same, but they're actually very different. They're interrelated, of course, but they don't mean the exact same thing. And a lot of people use them as synonyms when they actually are not. So, let's say hypothetically, I have a glass and I fill it up with water and I have ice cubes in it. The question is, why does the ice eventually melt? And I'm pretty sure a lot of you would say, well, the ice eventually melts because it gets warm, it heats up. And we have to realize that heat and temperature and energy are all interrelated. So the first thing that we have to realize is that the temperature is extremely important because the temperature, so when we're looking at temperature, it tells us how much thermal energy I have in my object because temperature is the degree of particle agitation, right? That temperature is basically how I measure this degree of particle agitation. And thermal energy is how much my particles move. So when I'm talking about objects that have a high thermal energy, so objects that move very quickly, well, their temperature, so how much the particles are moving, is going to be high. Whereas objects that are moving very slowly at the particle level, they're going to have a low temperature. So when we're looking at my water, right? So we said that the water had a temperature of 0 degrees. So that means that my water, the liquid water, has a relatively high amount of particle agitation. Whereas my ice cubes at 0 degrees, because my ice is in a solid state, will has a low amount of particle agitation. And you're probably saying, well, it's because the water, caused the ice cubes to melt. Well, this transfer of energy is what heat is. So the reason why my ice cubes melt is because the water that it's in has a higher amount of particle agitation than the ice cubes, and the energy, so my energy from the water, basically gets transferred into the ice cubes, causing the overall energy in the ice cubes to increase and therefore melt. So what this means is that thermal energy is the energy contained in my object due to my particles agitating. And temperature is really how much these particles are moving. So temperature is the scale to measure all of my thermal energy. So remember, and this is where we have to realize from our particle theory. So if we're looking at our particle theory, we have on Earth naturally 3 states of matter. We have solid that has the least particle movement. And this is due to a high degree of bonds in between each of the particles in the solid. And if we go all the way to the extreme, gas has the highest degree of particle movement. And this is pretty much due to no molecular bonds holding the individual molecules together. And liquid, as we can pretty much see, is that intermediate state between solid and gas, where the amount of particle movement is a moderate amount. And this is due to weak, also low degree, so weak, so low degree of bonds. And when we're actually going between our different states of matter, well, how these bonds are broken has to do with the amount of particle movement that is incurred by the material, which is usually done by increasing its thermal energy or decreasing its thermal energy. So, and this is something that we know, that when we're going from solid to liquid to gas, we pretty much are adding thermal energy. And when we're adding thermal energy, the particles start to move more. And once it gets to that temperature where I have a phase change, I'm basically breaking those bonds and entering into the next phase. Now, the opposite obviously is true, that if I'm removing thermal energy, my particles are moving slower. And if my particles are moving slower, they can slow down to the point where I'm at the precipice where more molecular bonds between the particles are being formed. So heat is basically this transfer of thermal energy from one object to another object. So when one object is gaining in thermal energy, the other object is losing in thermal energy. And heat is always moving from an area of high energy to an area of low energy. So actually, when we're going back to our water and ice cubes, right? Our ice cubes had low energy. Why? Because our temperature was at 0 degrees Celsius. So this is showing a low amount of particle agitation. Whereas our water had a high amount of energy. Well, higher amount of energy, because it was again at 20 degrees Celsius. And basically we had heat, so an energy transfer from the water to the ice cubes, ultimately causing my ice cubes to, so to speak, melt. So if we're looking at a recap, right, temperature really is based on how much energy is vibrating in the object, and heat is the act of transferring that energy. And heat is always going to be moving from areas of high energy to areas of low energy. And this pretty much brings the concept of absolute zero. Oh, but before we do that, how does heat move? So heat pretty much moves in 3 ways. Radiation, so moving through electromagnetic waves, so light, X-ray, microwave. Conduction, so that as done by a solid contact between 2 objects. And convection, so when we're talking about convection, this happens in liquids. So hot part of the liquid rises due to a lower density, and then it cools, and then it sinks where it goes to your because of a higher density, and then you have a circular motion. So examples where we have heat moving in convection, so this would actually be magma in the earth, and the result of this is the movement of tectonic plates. Okay, When we're talking about conduction, so things like stoves, things like kettles, right? All of those are basically transferring heat through conduction. And then radiation would basically just be through electromagnetic waves. Now, if we're looking at absolute zero, so absolute zero is the temperature at which particles cease to move. And when we're saying particles cease to move, that means there is no thermal energy. Because again, if we're looking about thermal energy is defined by the degree of particle movement. So if particles are stopping to move, that means there is no thermal energy because there is no particle movement. And this happens at minus 273 degrees Celsius or 0 degrees Kelvin. And Kelvin, again, is one of the many scales that we have for temperature. Because if we're looking at common ways to measure temperature, we have degrees Celsius, which is pretty much degree of temperature used in the Commonwealth. We also have degrees Fahrenheit, which is primarily used in the United States. And then we have Kelvin, which is named after Lord Kelvin. And this is pretty much used predominantly in science, so for chemistry, when we're talking about thermodynamics. And the 0 scale for the measure of unit for Kelvin is actually absolute 0. So I hope this helps describe the differences between heat and temperature and thermal energy and how they're all interconnected, but they all mean slightly different things. That heat is the transfer of thermal energy from one object to another. That temperature is a measure of how much thermal energy you have in the object, and that thermal energy is the degree of particle movement in the object. Have a nice day.